Today we're going to be sketching a rational function, and we're going to be looking at all of the things that we did in the last video, like maxes and mins and inflection points. So here's your rational function, x squared minus 2x plus 4 all over x minus 2. And if you want to shut the video off at any time and do some of these things on your own, that would be great. Or you can just listen to me and just remember what you have to do on these problems. First of all, if you want to get the y-intercept, you let x equal 0, so you would have 4 over negative 2, which is negative 2. So we'll go down here on the y-intercept and plot that, 0, negative 2. If you want to get the x-intercept, what you have to do is set the numerator equal to 0. So we have x squared minus 2x plus 4 equals 0. This is unfactorable because there are no factors of 4 that add up to negative 2. And if you wanted to try the quadratic formula, x equals 2 plus or minus the square root of b squared minus 4ac, turns out to be a negative number because it would be 4 minus 16. 4 minus 16 is negative 12. So that would mean that there are no x-intercepts because you would get an imaginary value after you use the quadratic formula. So there are no x-intercepts because b squared minus 4ac is equal to a negative number. So there are no x-intercepts. There's the one y-intercept of negative 2. And now our job is to go through and find some extremas. So we're going to find f prime of x. And like I said, I encourage you, if you haven't shut the video off, just shut the video off now and get the first derivative using the quotient rule. Or if you want to listen to me go through it, that would be fine too. Bottom times the derivative of the top minus top times the derivative of the bottom the derivative of the bottom is 1, so I'm not going to write that, all over the bottom squared. Oops, x minus 2 squared. And if we cleaned this up a little bit, we would have to FOIL this out. And the top FOILed out is 2x squared minus 6x plus 4. And then you just apply this negative to all of these terms inside the parentheses. So that would be minus x squared plus 2x minus 4 all over x minus 2 squared. Oh, in the very beginning, you should probably note that the domain is all real numbers except for 2. So over here on the side, you might want to write the domain is all real numbers except for negative 2, or except for positive 2, sorry. So anytime you get a 2 in any of these computations, you can just disregard it because it's not in the domain of the function. So simplifying this numerator down, you just get 1x squared minus 4x all over x minus 2 squared. So setting the first derivative equal to 0 and solving for x, or undefined, you'd get x equals 2 as undefined, but remember 2 is not in the domain. So x would be equal to, if you factored this, it would be x times x minus 4. So x would be equal to 0, x would be equal to positive 4, and in the denominator, x would be equal to 2, but we would cross that out because 2 is not in our domain. So those are possible extremas. X equals 0 and 4. And to find out if they're actually extremas, we'll take the second derivative of this function. And the second derivative is bottom times the derivative of the top, quotient rule again, minus top times the derivative of the bottom, all over the bottom squared. So x minus 2 squared squared is x minus 2 to the 4th power. Come in on that a little bit. And to simplify things down a little bit, you could notice that we have an x minus 2 is a common factor in all three of the terms. So this x minus 2 can cancel out with one of these x minus 2's, and that 4 becomes a 3, and this 2 becomes a 1 because we've taken one of those x minus 2's out. And then if you clean this up a little bit, you'd have to FOIL x minus 2 times 2x minus 4, and after you get done foiling that, you get 2x squared minus 8x plus 8. And then you negate all these terms. Remember, you have to distribute the 2 throughout the parentheses. So this would be a minus 2x squared, and minus a negative is plus 8x. All over x minus 2 cubed. And then this simplifies down. The 2x squareds go away and the 8x goes away, and what you're left with is just an 8 over x minus 2 cubed. So there's your second derivative. So if we want to do a second derivative test on these possible extremas here, the second derivative test says that we're going to do f double prime of 0 and just see if we get a negative or a positive number in here. So if we put an x equals 0 here, we're going to come out to be a negative. And a negative second derivative means it's concave down. CD, concave down. So x equals 0 is a min. And if we do f double prime of 4, our other possible extrema, if we plug in 4 to this second derivative, we get a positive value. Positive value means the graph is going to be concave up. So x is equal to 4 is a max. So now what we do is just plug in x equals 0 into the original function. F of 0, well, we've already found f of 0 because it's already on our graph. F of 0 is equal to negative 2. So 0, negative 2 right here, that is going to be a local max. And then we're going, or local min, wait a minute, what did I wrote this down wrong, I'm sorry. X equals 0 is local max. Sorry about that. And concave up, x equals 4 is local min. Sorry. So we'll write this as a min. Going too fast, I guess. So f of 4, when you plug in 4 to the original problem, 4 squared minus 2 times 4 plus 4 all over 4 minus 2, I think you're going to get 6 out of that. So 0 comma negative 2 is our min, max. I keep saying this wrong. And 4 comma 6 is our min. Hopefully I'm on there. Yep. So those are some important things that we're going to be graphing. All right, the next thing we can look at is an inflection point. If you take the second derivative and find the critical values, x equals 2 would be the only thing that would make this 0 or undefined. So that x equals 2 could be a possible inflection point. But if you remember way back at the beginning, we said the domain is all real numbers except for 2. So we'll cross that out because x equals 2 is not in the domain. We don't consider it for anything. All right. Now the next thing we have to do with rational functions is, this is just a review from last fall. We have to find the vertical asymptote. And the vertical asymptote is just when the denominator is equal to 0. So x equals 2 is a vertical asymptote. The next thing we want to look at is a horizontal asymptote. But because the degree of the numerator is bigger than the degree of the denominator, we have none. But we do have a slant asymptote because the degree of the numerator is 1 more than the degree of the denominator. So all we have to do is divide the numerator by the denominator. And because the denominator is just x minus 2, we can use synthetic division. You don't have to go through long division. All right, so x minus 2 down at the bottom means outside our synthetic division is a positive 2. And on the top we have 1, negative 2, and 4. So going quickly through the synthetic division, We have a remainder of 4, but you ignore that remainder. So y equals x, y equals 1x, and there's nothing else here, is going to be our slant asymptote. So y equals x. And then we want to get concavity. So we're going to set up our second derivative sine table. And the critical number in our second derivative sine table was x equals 2. Even though it's not in our domain, I'm going to put it on the sine table. The function doesn't exist there, but the concavity does. So if you take a second derivative of anything less than 2, you plug in anything less than 2 into that second derivative and you get a negative value out of that. Anything greater than 2 and you get a positive value out of that. So we have this function being concave down for negative infinity up to positive 2, and we have a concave up part of the graph going from positive 2 to positive infinity. I think we've got everything that we need. We've got our asymptotes, we've got our concavity, we've got our mins and maxes and our x-intercepts. So now it's just up to us to put this in a graph. So use my pencil here. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. All right, where do we start? We've got our minimum here at 0, negative 2. We have our vertical asymptote at x equals 2. So hopefully this will be straight. And then we have a slant asymptote at y equals x. And we have our minimum here. We have our maximum value at 4, 6, which is up here. And then we have a concave down part of the graph over in this. When x is less than 2, it's concave down, so it's just coming down like this. Concave down. And then this part of the graph is concave up. This is the minimum point, so it doesn't get any lower than this. And then it comes up like this and gets closer to those asymptotes, but don't touch them. And then I think we've got everything that we need for this beautiful graph of our rational function. And that's it. And the rest of the night, just take a look at your old notes and we'll have a quiz tomorrow. Have a great night.